Hello, we are back with Chapter 6, Lesson 6, Simple Interest, and now we're taking a look at Example 3, Computing Total Savings. So this problem says that John's parents deposited $1,000 into a savings account as a college fund when he was born. How much will John have in this account after 18 years at a yearly simple interest rate of 3.25%? All right, so we know that we're dealing with simple interest, so we can use our simple interest formula. I equals P times R times T, okay? So yeah, let's go ahead and define our variables. So we don't know how much interest was accumulated at this time. So that's what that's one of the things we need to determine. Do we know the principal? Yes, we do. The principal is $1,000. That's how much was deposited when John was born. So P equals 1,000. When he was born, how much will John have in his account after 18 years? Okay, 18 years is referring to the time. We know the time is 18 years. That is T. So T equals 18 years. And at a yearly simple interest rate of 3.25. So we know that interest is 3.25%. Now we know that we have to write the rate as a decimal. The percentage is a decimal, so I'm just going to go do that over here. 3.25% as a decimal. We're going to move this decimal over 2 places. So it ends up being 0.0325. So the rate equals 0.0325. And that is the rate. Now we can go ahead and just substitute all those values in for the variables and figure out how much interest has been accumulated after 18 years. So we're going to find I equals the principal, which is 1,000, times the annual percentage rate, which is 0.0325 times 18. Okay, for time. We're just going to go ahead and figure that out. We're going to put in our calculator here. So I'm going to turn it on. Turn it on again. Okay, clear it out. Okay, so we have 1,000 multiplied by 0.0325 times 18. And hit enter. And we end up with an interest of $585. So that's how much interest we've accumulated after 18 years. So I'm going to read this question one more time to figure out what the question is asking. John's parents deposited $1,000 into a savings account as a college fund when he was born. How much will John have in his account after 18 years? So it is asking how much will John have in the account after 18 years. So that is asking us for the amount. And remember, the amount is found by taking the principal and adding it to the interest. So to find the amount, we're going to take the principal, which we already know is 1,000, and add it to the interest that we just figured out, which is 585. So we're going to go ahead and substitute those values in to figure out the amount. The principal is 1,000. The interest is 585. And if we add those two, we get $1,585. So we can say John will have $1,585 in his account. And then we'll just identify our answer there. And there you go. So now it is your turn, ladies and gentlemen, to check it out. Now, before you start check it out example 3, I want you to notice that I want you to check it out example 3 is very similar to this example, and I want you to show your work exactly like this. Write the equation, define your terms, substitute the values in, figure it out, write another equation, substitute those terms, write your answer, okay? So use this as a guide and to solve this problem. All right, where's my friend? Oh, there's a pause dragon. Remind you that you need to pause your device. When you get done with check it out example 3, press play, and we will see how you did. All right, see you in a bit. See you in a bit. All right, we're back with check it out example 3. Let's go ahead and read it. Bertha deposited $1,000 into a retirement account when she was 18. How much will Bertha have in the account after 50 years at a simple interest rate of 7.5%? Okay, we know that we're dealing with simple interest, so that means we can use our formula. I equals P times R times T. Now, you have to remember, this formula can only be used when we're talking about simple interest, okay? So let's figure out which of the variables we know. So it says Bertha deposited $1,000 into a retirement account. Boom. That is our principal. That is what P is. So P is going to equal $1,000. P equals $1,000. What other information is, okay, Bertha deposited $1,000 into a retirement account when she was 18. How much will Bertha have in this account after 50 years? Oh my goodness, that's a long time. That is our time, 50 years. So that's what T equals. T equals 50. How much will she have in her account after 50 years at a simple interest rate of 7.5%? Boom, there we have it. There is our rate, 7.5%. And remember, we have to convert that into decimal form. So I'm going to do that here, 7.5%. To change it to a decimal, we move it over 2 places to the left. Put the decimal there, add a 0. We end up with 0.075. So that is our rate, 0.075. Okay, and our interest is one of the things that we're trying to figure out. Okay, so let's go ahead and substitute the values in. So we're trying to find the interest. P is $1,000. The rate is 0.075. And time is 50. Okay, let's just go ahead and plug this into our calculator. So we have 1,000 multiplied by 0.075 times 50. That equals interest. That is $3,750. That's a nice little amount. Perfect. Okay, let's go back to the problem and read it and see what it's asking. So Bertha deposited $1,000 into a retirement account when she was 18 years old. How much will Bertha have in this account after 50 years? So it's asking, how much will Bertha have in the account? It's asking for the amount, okay? And the amount is found by taking the principal plus the interest. So the amount is found by taking the principal, which we know, right? The principal is $1,000. And then we're going to add it to the interest that was earned over 50 years, $3,750. So we're just going to go ahead and add those two things together. So the principal is $1,000 plus the interest earned, $3,750. I can add these pretty quickly. You just go 1,000 plus a 3 is 4. So the amount is $4,750. So we can say Bertha earned $4,750 in her account. And if you got that one right, great job. But make sure that you showed your work. If you didn't show your work just like this, you need to go ahead and revise so your work looks just like this. Okay, let's move on to example number 4. Here we go. What is example number 4? Example number 4, example number 4, example number 4. Okay, example number 4 is finding the rate of interest. So this says that Mr. Johnson borrowed $8,000 for 4 years to make home improvements. If he repaid a total of $10,320, at what interest rate did he borrow the money? Oh, okay, so this one is very interesting. Mr. Johnson borrowed $8,000 for 4 years to make home improvements. If he repaid a total of $10,320, at what interest rate did he borrow the money? Okay. So here, what I see is we are talking about a total amount. So right off the bat, they are telling us what the total amount is. The total amount he repaid is $10,320. That means that we are dealing with this formula. The amount equals the principal plus interest. And this amount, this is a very tricky problem. The amount is $10,320. Okay. It also tells us the principal. $8,000 is the principal. Right here, that's our principal. So P equals 8,000. But it does not tell us the interest earned at this point. But we can figure that out, okay? So let's go ahead and substitute these values in to determine what the interest earned is. So the amount is $10,320 equals the principal, which is $8,000, plus the interest earned. Now we're trying to isolate and figure out what I is, so we need to get I by itself. That means we need to get rid of this 8,000. Well, how is the 8,000 related to the I? It's related to the I through addition, so we need to do the inverse operation of addition, which would be subtraction. We're going to subtract 8,000 to both sides of the equation. When we do that, these cancel out. We now have I on this side of the equation by itself, which is what we want. I subtract here, 0 take away 0, 0, 2 take away 0 is 2, 3 take away 0 is 3, and then 10 take away 8 is 2. So the amount of interest earned would be $2,320. Perfect. Now let's go ahead and see what the question is asking. Mr. Johnson borrowed $8,000 for 4 years to make home improvements. If he repaid a total of $10,320, at what interest rate? Ooh, this even gets trickier. Did he borrow the money? At what interest rate? So since we're talking about interest rate, we know that we're going to be dealing with the simple interest formula. I equals P times R times T. Now we already know the amount of interest that was earned. It was $2,320. But the principal we know as well, that is $8,000. We don't know the rate. That's what we're trying to figure out is the rate. Do we know time? Do we know time? It says for 4 years. Yes, we do know the time. So the time, T, equals 4. So what we're going to do is we're going to substitute all these values into this equation and then solve and figure out what the interest rate is. So the interest earned is $2,320 equals the principal, which is $8,000, multiplied by the rate multiplied by time, which is 4. All right, so we want to get R by itself. Right now, R is being multiplied by 8,000, and it's being multiplied by 4. So what I'm going to do is I'm going to multiply these two together to kind of like simplify the equation. So 2,000, I'm rewriting this. 8,000 times 4. Okay, I'm going to do that off to the side. 8,000 times 4 would be 4 times 0, 0, 4 times 0, 0, 4 times 0, 0, 4 times 8 is 32. Okay, it's 32,000. So 32,000 R. And we're trying to get R by itself, so that means we need to get rid of this 32,000. What do we know? We know that it's related to R through multiplication, so we have to do the inverse operation of multiplication, which would be division. We're going to divide both sides by 32,000. Okay, 32,000 divided by 32,000 is 1. 1 times R is R. I'm just going to go ahead and figure out what this is really quickly. Yes. If we go 2,320 divided by 32,000, we end up with, oh, very, very interesting. We end up with 0.0725. Okay? What we need to remember about this, I'm going to move this up here. The rate equals 0.0725. We need to know that this rate is in the form of a decimal, right? This is the percentage, but it's in the form of a decimal. So to get the percentage, we have to convert this from a decimal back into a percentage. So to do that, we're going to have to move this decimal place 2 places to the right, and we end up with the rate being 7.25%. So we can just say the interest rate was 7.25%. All right. Very, very good. Okay, now it is time for you to check it out. Check it out, example 4. Now, example 4, check it out, is going to be very similar to this problem. And once again, as you're solving this problem, I want you to make sure that you're writing the equation, defining the terms, showing all your work, writing another equation, defining some more terms, showing the work. So you need to use this as a guide. Your problem should look like this. And if it doesn't, that means you need to go ahead and do it over until it looks like this. Okay, this is what we're going for. This is what we're going for. Sorry about that voice. I don't know why I did that. It just came out. Okay, anyways, it is your turn to check it out. Go ahead and pause your device. Oh, thank you, Pause Dragon, for reminding us to pause our device. Pause your device. When you get done, press play and we'll go over your results. All right, see you in a bit. See you in a bit. All right, we're back with Check It Out example 4. Let's go ahead and read it. Mr. Mogi borrowed $9,000 for 10 years to make home improvements. If he repaid a total of $20,000, at what interest rate did he borrow the money? Okay. So what do we have here? We have Mr. Mogi borrowed $9,000 for 10 years to make home improvements. If he repaid the total of $20,000, oh my goodness, it's giving us that total amount again. So if it's giving us the total amount of $20,000, we know that we are going to be using the formula A equals P plus I, where the total amount is going to be $20,000. The principal is $9,000. I'm going to go ahead and define our terms. P equals 9,000. And the interest at this point, we don't know what that is. We need to figure that out. So we're just going to go ahead and substitute these values into this equation. So A is the same thing as 20,000. equals the principal, which is 9,000 plus the interest. Okay, we're trying to get this I by itself, so we have to get rid of that 9,000. How is it related to I? It's related to I through addition, so we have to do the inverse operation, which would be subtraction. We have to subtract 9,000 to each side. 9,000 take away 9,000 ends up being 0, so now we have I isolated, which is what we want. And then we're just going to subtract. 0 take away 0, 0, 0 take away 0, 0, 0 take away 0, 0, and I need to borrow, making that a 1 and that a 10. 10 take away 9 is 1, and then we drop the 1 down. So 20 take away 9,000 is 11,000. That is what our interest is. Interest equals $11,000. Okay, let's go back to the problem and see what they're asking us. Mr. Mogi borrowed $9,000 for 10 years to make home improvements. If he repaid a total of $20,000, at what interest rate? So it's asking about the interest rate, which means we're going to be using the simple interest formula. The amount of interest equals the principal multiplied by the interest rate in the form of a decimal times time. So let's go ahead and define our terms. We know that the amount of interest that was accumulated was at that $11,000. The principal is $9,000. The rate, we don't know that. We're trying to determine that. But what about the time? Do we know what the time is? Well, yes, the time is 10 years. So that means that T equals 10. And now we just need to go ahead and substitute all these values into the formula. So the interest is 11,000. The principal is 9,000. The annual percentage rate is what we're trying to determine. And time is 10. Okay, we are trying to get R by itself. In order to do that, we need to simplify this side of the equation first. We need to multiply 9,000 times 10, which when you multiply 9,000 times 10, you can just add another 0 to the end of 9,000, and you get 90,000 R over 11,000. And we're trying to isolate R and figure out what it is, so we need to get rid of this 90,000. 90,000 is related to R through multiplication, so we need to divide both sides of the equation by 90,000. And then 90,000 divided by 90,000 is 1. 1 times R is R, so now we have R by itself. I'm just going to go ahead and figure out what 11,000 divided by 90,000 is. So 11,000 divided by 90,000 is, all right, it is 0.12222, and it's repeating. So 0.1222. Okay. That is our rate, but remember that our rate is in the form of a decimal, so we need to change it into a percentage. So to do that, remember we just need to move this decimal place over two spaces to the right, and we end up with our rate being 12.2%. So the interest rate was 12.2%. So if you got that one right, yoke it, you did a great job, and we'll see you next time. Bye-bye. See you later.